Off we go. All right. So today I want to talk about something that I believe is at the core of the strong fit system, is the idea of baseline versus reaction. I was reading a paper and we seem to, like everybody talks about serotonin, but I think that's a mistake, honestly. Like there seems to be a foundation to the baseline, the human system, and it seems to be based on noradrenaline. What's very interesting about that is noradrenaline is a neurotransmitter for the sympathetic nervous system. So studying anxiety, depression, and schizophrenia, we saw that whenever you had a hypo, so that means lesser than normal, than the baseline, you would see, for example, that's where depression lives. You would see what is called the negative symptoms of schizophrenia and everything. And a hyperactivity toward noradrenaline would mean more toward the what they call the positive symptoms of schizophrenia, like hallucination, stuff like that, and everything that leads toward the anxiety. So it seems that noradrenaline kind of seems to be deciding a lot of those issues. When it's too low, then you get the negative symptoms of schizophrenia, you get depression. When it's too high-ish, right, you get more toward anxiety and things like this. So noradrenaline is something that I've been studying a lot. It seems to be the foundation of how the system reacts to the world, which would make sense if we look at it as a transmitter for the sympathetic nervous system. So knowing at this, I started to look more precisely at this. What you see is noradrenaline mostly is being produced in what is called a part of the brain called the locus coeruleus, right? Very important part. That part controls a lot of our behavior and things like this. I was like, all right, so then you start to go a little bit further and further. And what you find in the locus coeruleus is that lactate is something that triggers the locus coeruleus for the production of noradrenaline. So why does this matter? If you know me, you know I talk about lactate all the time. Lactate is the fuel that we use for about everything, for muscles, right? It's produced mostly during explosive training. Whatever uses type 2 muscle fibers, that produces lactate. Type 1 muscle fiber absorbs lactate. All this is going to matter because what we're going to see is that noradrenaline, levels of noradrenaline and level of lactates are linked. And then when we see what we have seen, and again, based off strong fit, is lower level of lactate will go toward depression, higher level of lactate unused will go toward anxiety. Exactly the same idea as noradrenaline. So I was like, all right, so there's a relationship between noradrenaline and lactate. And I was like, okay, what is it? So I keep going a little bit further and further and further. And we end up, right, so this triangle like right there, right? And I'm like, all right, so let's go a little bit further. And then what I realize is that something called the Orexin neurons that are located in the lateral hypothalamus actually seems to be a very, very important part of the equation. So the Orexin neurons are, not all neurons are born equal, right? The Orexin neurons are a specific one, most of them, again, in the lateral hypothalamus. But there's a number of things that go with them that become very, very interesting. So if I go on this side, first of all, you start to see that orexin neurons are lactate sensors. They can tell exactly what the concentration of lactate in the brain is. So I was like, all right, so that's very interesting. And on top of that, what you see is they can tell the level of glucose also in the brain, and they act as sensors. And the number one fuel for those orexin neurons is lactate. So I'm like, So now we're starting to get closer. But most of the lactate that you see, so if I use that, it's important to understand how the brain works. So in the brain uses mostly lactate as fuel. It does not use glucose. It transforms glucose into lactate. How? By using something that is called the astrocytes. The astrocytes are just cells that they do a lot of things, but they take the glucose and they turn it into lactate. The major fuel for the brain is the lactate produced by the astrocytes. And so that's what we see those orexin neurons doing, is they like the lactate produced by the astrocytes, and so they monitor the level of glucose into the brain to make sure that the astrocytes have enough to produce enough lactate to fuel the orexin neurons. Whenever glucose or lactate is low, they stop firing as much. They are less excitable. And so that's going to come very, very importantly. So the brain has two ways of getting lactate. First is through the astrocyte, and if not, it gets it from the body, from muscles producing a lot of lactate that sends it to the brain to fuel what seems to be the orexin neurons. It feeds all neurons, but those ones, man, they seem to be designed for lactate because they act as sensors first, and they use primarily the lactate as fuel. So that becomes very important. So those orexin neurons, we see them on everything. We see them in eating disorders. We see them in problem with wakefulness. So narcolepsy is directed from there. And we also see a relationship with mood. So when I saw that there was a relationship between mood, like feeling sad is seen as a low excitability of the orexin neurons. So that means that feeling sad being a low excitability means there's a low energy substrate quantity into the brain. So that means that low glucose toward the astrocyte, so low lactate availability into the brain because of the lack of excitability of the orexin neurons will lead to basically being sad. So sadness as relating to the amount of lactate that is in the brain. So we go back to the same place we were.
So that's why you tend to see people always wanting to give more glucose and sugar.
Exactly.
Because they don't have the transmitters to bring the lactate to the brain unless
right.
they go through the sugar.
Right. And so raising the glucose level will calm down the orexin level. Right. Now, that does not mean you have the lactate. So the astrocyte have to promote correctly. But if you start to break down the chain and you end up with low glucose, low lactate, and you bring the glucose in, it will signal to the astrocyte to produce the lactate that would have an effect directly on mood. Yeah. So that means that having sugar would directly take you out of sadness, would directly up your mood.
Right. But they don't bring
But that's just a trick, exactly. Yeah. Now it's a pill, basically, which we find everywhere. So what's also, so I'm going to get into this, but that's the number one. So this is why also you see the orexin neurons are linked to eating disorders, because food will affect directly that affect directly the mood. So then you start to see the emotional connection between food and behavior, right, like this. So on top of it, what becomes very interesting on that side, that means that on top of it, the orexin neurons are very susceptible to the metabolism of the cell. So this is potassium ATP, that's the potassium sodium pump, ATP that I talk about, right? The orexin neurons are very, very sensitive to the metabolism of the cell. So that means like cells that work well within the sodium potassium pump, maybe, unless Lynn was right and it's another system. That's another rabbit hole. I'll go into a podcast. But they're very sensitive to the metabolism of the cells. So all that stuff become important. But what I want to talk about today also is this. The downstream target of the orexin neurons is the RAF nuclei. What matters is the RAF nuclei is where the serotonin is being produced. Okay. So people always tell you that carbs goes toward production of serotonin. Well, yes, but as down the hill, right? Down the river. But before that, if you look at glucose, they go here and they go toward astrocyte to produce lactate, to go toward the orexin neuron that get the locus coeruleus going, that get the lactate going, that get the noradrenaline going. And so once you have that, then at the end, they trigger the serotonin. And so we go, ooh, serotonin means happiness. I'm like, maybe it happens here. And serotonin is just we're still not sure what serotonin does, by the way. It's very, very complex. So, but we have associated serotonin with happiness. I'm like, maybe we fuck it up completely. Maybe actually what the carbs do is they just allow you to have excitation right here, that excites there, that lifts the level of noradrenaline, that lifts the level of sympathetic, that brings you into a fight. We know it affects your mood. Right, it affects your wakefulness, and we know the levels of noradrenaline have to do with the baseline. Now you're happier. maybe it has nothing to do with serotonin. So it seems to me that, again, we're going back to lactate. By the way, that means that sugar is not the only way to get there. Exercise would get the same thing.
So then, but they're using sugar as a no matter what passive positive
Exactly,
reaction.
as a very passive reaction
Yeah.
to get to that. The body will adapt. So you see that in the selfish brain theory. So remember, back to metabolism, is once your metabolism is fucked enough, the sugar doesn't even make it to the brain. It's being used, like that's a selfish brain theory. It's basically goes straight to fat because you take in so much sugar that you have insulin issues and all that stuff. You can't even get the sugar to the brain. Yeah. So then you need more sugar. That's the selfish brain theory because the brain cannot use the energy yet. And remember, all that sugar has to go toward the higher brain function first. The hypothalamus, he gets what he can. But so you start to see all those problems. And as your metabolism gets worse and worse and worse, less and less sugar makes it to the brain. So you need more and more of it. And then you could see where that leads you downhill really fast. What we need to do is basically get lactate. So obviously some glucose levels are important for the astrocyte, but if we can produce lactate correctly, especially in the right environment, then we're going back to have high levels of noradrenaline because the training itself brings on the fight. Right. So brings on the sympathetic nervous system and all those levels go up and now the baseline is where we want to be. So the key is to get there. Yeah. Is to get to the baseline, we want to get there. So the idea of serotonin is not, I don't think is correct. Well, it's the downhill area, but that's not what interests us. What, by the way, is very interesting here with the RAF nuclei is this is the center for the circadian rhythms. Yeah. Okay. So you could see that the orexin neurons target directly downhill the serotonin neurons, but through the RAF nuclei. So what it does is it takes care of our circadian rhythms. And serotonin, again, is just at the end of that. So serotonin might, who knows, maybe it's just to help with circadian rhythm, but nothing else. Right. Circadian rhythm is also decided by food. We know that, right? Gut flora, food. So now we're back to here. Right. So all it tells me is that this orexin neurons and the lactate are the key to the whole behavior. So I think that's why we see exercise doing what it does because, and remember, by the way, the sugar also triggers a sympathetic nervous system response, but a passive one. Right. Whereas when we have exercise, what do we have? We have baseline and we have reaction to stress. We are training the reaction to stress as much as we are lifting the baseline. And that's where we'll have the effect on the sympathetic. As a neuron transmitter, the noradrenaline, the lactate, the orexin neuron, then everything becomes, goes together. If you stop just with the sugar, you could see where the problem starts. And so this seems to be the key right there. So the whole stuff about serotonin, I don't think is the point. The point is the orexin neurons because of the noradrenaline. This seems to be the key. When you look at pills, more and more what they have now, because at first antidepressants were mostly serotonin based, and now they have more and more noradrenaline. So they give you the serotonin and the noradrenaline now, because serotonin is just down the hill, which kind of helps, but once they act, they pump there, they're trying to go toward basically this that doesn't do it enough. So if we could understand more how the brain works in that aspect, we could bypass a lot of that stuff, or the pills and all that stuff. But it always, so that one is what produces noradrenaline. So you always come down to this. You see wakefulness, you see the mood, you see the food. It goes back to how do we get to that? And it goes back to, so a lot of eating disorder, so anxiety, depression, if we look at it, is a dysregulation of the sympathetic nervous system. So for us to be able to impact all this, this is where our fight is. And I think that's why exercise has been working so well for us, is because you always end up in here. That's the key to that's the keys to the kingdom, is on that side. I mean, it's all baseline versus reaction because of that. We have to influence the sympathetic nervous system correctly. We get the neurotransmitters going, that forces all this to engage, because it's a two-way street always, right? Yeah. But you can see where food can come and create a short-term solution that will just wreck the entire system, because what you're doing is you're tricking the system, but that lasts only so long. Even if the glucose levels are very high, that does not mean the astrocyte will necessarily turn it into lactate. They only work in a specific environment. So just having the glucose level might trick the orexin neurons into firing at first, but eventually, first of all, you won't get the glucose anymore. And second of all, just because you get the glucose does not mean the orexin neuron won't catch up on what you're doing and give you less and less of an answer. So the pills will act as a pill at first, but to me, it's very short-lived. You'll need always, and then you'll need more and more and more, which is exactly what we see. That's why a little bit of sugar was great on the protocol when we train, but the second you do past that, you always end up falling. Because you basically, it's passive, it's raking this. And the second you do that, everything goes. Serotonin being downstream. But so the importance of the circadian rhythms, again, is being brought forward, and the dysregulation of the sympathetic nervous system. That seems to be the base of the system the more I study it. And this fits exactly what we've been saying for the 5 years. I did not know this 5 years ago, that's for sure. I did not know this a year ago. But the more I study all this, the more we end up back in the same place. And this is the number one thing. You see lactate everywhere. You see lactate even in there. All neurons, lactate is number one fuel for the brain. Like it just comes back to that. When lactate is being produced at a certain level, so like burn the question and everything, it opens up the blood-brain barrier so that the lactate can go into the brain and fuel it even more. At first, it's somewhat being blocked, but the more you train, the more you have, the more it's tried to go through. So that means that proper training can take place of sugar a lot. Right? You still need some glucose levels for the astrocytes, but it can learn to rely more on exercise. Yeah, which is what we see as well. And then so remember, like we always said, to get out of depression, you need the fight mode. That's because we raise the baseline. And that happens to noradrenaline, that happens to lactate, tac, tac, tac. So every time we need the SNS, the fight mode to go up, we need technically, if you look hormonally speaking, and you know, peptides and neurotransmitter and all that shit, you need that to go higher. You need more of that to get to there. So that, you need this, you need that. Yeah. Okay. And to get there, this is linked to it. And so the orexin neurons, when they're excited, they go directly into getting this part of the brain excited. Excited like in the neuroscience type, in order to produce adrenaline. You see adrenaline being produced other places, but that's really the number one, the number one into the brain. Okay. So the hypothalamus is actually a very important part of that. So the lateral hypothalamus is where you find the orexin neurons, and that seems to be a very important target. The hypothalamus, you'll see it a lot in eating disorders as well. Does that make sense? I mean,
when you say that you see that a lot in eating disorders, you see the root cause.
You see it. Well, the problem is we can never really truly imply causations, because everything is a two-way street. But we see correlation. So when you see eating disorder, you see the hypothalamus firing like nonstop. You see a dysregulation at this level on all eating disorders, one way or another. Whether it's anorexia or bulimia, doesn't matter. This seems to be completely dysregulated. Okay. It sends shit all over the place that in quantities it should not be sending. Okay. It's a little bit like what you see with noradrenaline. When it's too low, you get depression. When it's too high, you get anxiety. The brain works not so much on specific, more is it going up or is it going down. We see that on serotonin a lot. It's more the increase of serotonin than the high level of serotonin that creates something. The brain reacts to changes, basically. And so whenever this goes up and down, that's when you see issues. Okay. And then, like the pendulum starts swinging, and that's what causes the problem. Same thing, like a high baseline can be fine, but then your reaction just adds to it. Then the pendulum starts swinging too much. So the key is to have a baseline that someone would like to be, like we want to have energy all day, but the correct reactions to stress so that we don't start crashing the system, because otherwise this has to be messed with, and to mess with this, here comes the entire system in place. So serotonin is important, but I don't think it's the key. I think the key is the noradrenaline. Now, you can never imply causation just with one thing with the brain. Everything is a two-way street, always, always, always. But there's certainly a strong correlation between all this. So from a practical perspective, again, to me, this is the key. Like, that's why I think training is the most important thing, and has such good effects on depression and anxiety and everything, because it will regulate the levels of lactate. And again, remember what the orexin neurons are. They're lactate sensors, and they use lactate as a primary fuel. So if we regulate this, we regulate their excitability. If we don't have enough lactate, they're not excitable, which means they react less strongly. So that would explain why it's so hard to get people out of depression. Because those babies, they don't do shit until they get those levels of lactate and glucose back to what they want. Yeah. So, but what you see depressed people do, they do cardio. Problem with cardio is type 1 muscle fiber, it absorbs lactate. So what they will need to do is do enough strength training that they start to produce so much lactate, which is past a very large degree, past 20 millimoles. So that means you have to actually hit it really hard in order to get the lactate into the brain, which would tell the orexin, okay, it's coming back. The problem is to do that, you need to die on the sled. Yeah, 20 millimole is a high level, and they're incapable of doing that. So I think that's why we're struggling, is we can't get them to produce enough lactate to actually get the brain to restart toward a higher baseline. And so if they could do the sled the way we want, they get better. That's what we see. The problem is getting them there. They love to do cardio because it takes away lactate, which fucks with those babies even more. And so they'll have sugar to make the difference, but you can't win that one. Because of sugar and insulin level, you cannot win this. So at the end, it comes down to burn down the questions. I mean, for depressed people, they need to produce enough lactate so that the whole chain can start again. And so eventually they'll get to the serotonin and then the easing up on the circadian rhythms.
You see, I mean, not why you see, but one of the correlations between people who are on medication and always having like that buffer line between the intensity.
Yeah. Yeah, because what that pill is doing is keeping this in the center.
Right.
Like most people, we all like this. If you look your level of testosterone versus cortisol, they go up and down, up and down. Noradrenaline goes up and down, and the pill, they make you here. Right. The reason for the pill is that you don't have the lows, because they feel so bad on the lows. Problem is you don't get the highs either. So they're so good at staying there that that's what they do. And so whenever this starts to go up, the pills are fighting that. So they have they have learned to never push past the center. So they don't go below that, but they don't go past that either. So, when the sled gets hard, you need to find, maybe not the anger, but like that, fuck it, push the fuck it button, right? They don't have they don't have a fuck it button anymore. They can't, because those fucking pills keep them in the center. That's why you hear like noradrenaline reuptake. Yeah. That's what they do, is like there's a certain level and then it stabilizes everything within closer to the center. To go back to work the next day, to feel less tired, to feel less. Yeah. Less tired, less angry, less hating your life, less everything. Less happy, less excited, less capable of fighting, less capable of loving. The first thing you start to see with all those fucking serotonin one is, like they don't want to talk about it, but all this shit, forget getting hard. Like, which, by the way, you would think as a side effect, they would mention it more often. But like the Zoloft and everything is, like, that's a perfect way to stop anxiety. Make sure you can't make love to your wife. I'm sure for anxiety, it's awesome. Like, it must be doing great results. But you could tell also why those pills, you see a lot of weight gain on that stuff. Like, we back here and everything. Yeah. If you start fucking with this, you don't want to do that. And this is a huge part of behavior as well. Locus coeruleus decides a lot of the behavior, because its behavior is the sympathetic nervous system. And we're going back to this. So dysregulation of the sympathetic nervous system seems to be the key of what we work on with anxiety, depression, all that stuff. It's here. This is what we have to target. Right. It's there. And so after that, we'll go into more into the next one, into the, observation versus prediction, and how it fits into this, but it's the same idea. That's, it's prediction versus observation. We're going to see that it fits into all that stuff anyway. But so noradrenaline, there's the key one. That's the important one. So sympathetic nervous system. Cool.